All right, so this was 4, 4. So we did a little bit of right triangle trig, and we did a little bit of using the unit circle on these bigger angles, okay? The first one is the right triangle, right? And I know that because 5 and 13 are not on my unit circle. So it says, given that the cosine of theta is negative 5 over 13 and sine of theta is greater than 0, find the following. As soon as you know it's not unit circle based, you should know to draw your triangle, put theta in the corner, realize that it may not be in the right location, right? I might have to go left or down. I'm just drawing this, and then I would fill in the negative signs. So the cosine is negative 5 over 13, right? I know adjacent would be the negative 5 because the 13 has to be positive. Now what I don't know is, I know the length of the other side should be what? What's our triple? 5, 12, 13. I know the length of the side should be 12, okay? But I still have to use this piece of information to determine if that's a positive 12 or a negative 12. Because that says sine is greater than 0, and I know the hypotenuse is positive, then I know it's a positive 12. Be careful, because if that had said less than 0, both the opposite and the adjacent sides have to be negative. So you need that piece of information to know if it's supposed to be positive or negative. So now I know that my sine is a positive 12 over 13. And my cotangent, which would be adjacent over opposite, excuse me, is negative 5 over 12. I promise you, you are going to see triples. I promise you they will save you time if you know them. But if you don't know them, you're going to have to use the Pythagorean theorem. Okay? And yet another thing that's going to save you time if you know it, just like your unit circle. All right, which leads into 3, 4, and 5. Remember that the odd whole numbers, like 3 pi, would be on the left of my unit circle. And I know at the left and the right, my tangent is 0. So this is 0. The secant of negative 3 pi over 4, first of all, just knowing it's an over 4, tells me my coordinate points are root 2 over 2 and root 2 over 2. So if I take that cosine, and I flip it, I get 2 over root 2, which gets rationalized and then simplified to just root 2. So I know the value of it is root 2. Now all I have to do is find the positive negative sign. If it's a negative 3 pi over 4, okay, we have two choices. Either go to positive 3 pi over 4, which is here, fold my graph along the x-axis, and that's where the negative would go. Or move clockwise instead of counterclockwise. 3/4 would be in between 1/2 and 1, which would be these if it was negative. And so either way, I know it's in the third quadrant. In the third quadrant, all students take calculus. Tangent's the positive one, which means that cosine and secant would be negative. Thank you, Derek. Go to my participants. Hi, Dylan. Thank you. I'll email Miss Pierce, but she might call home before I get to her, okay? All right, number 5 is 13 pi over 6. It is an over 6. The coordinate point at over 6 is root 3 over 2 and 1/2. I know the sign is 1/2. Now I look at 13 over 6 and convert that into a mixed number. That would be 2 and 1/6 pi, which puts me all the way around back into my first quadrant where everything is positive, so the sign would stay positive. So you will see unit circle based angle questions on, like moving forward on a test or whatever. You don't want them to take a long time. You want those to be the quick questions. They will not be initial angles on your unit circle, okay, because you obviously can have your unit circle. So it won't be something from 0 to 2 pi. Just make sure you know how to apply what you know. Questions? All right. So 4, 5 is the graphs of sine and cosine. We are now going to take our unit circle points and coordinates and trig functions and apply them to an xy axis, okay? So we're going to start with the sine curve. This is my initial shape of a sine curve. It starts at 0, 0. It goes up to 1, comes back down to 0, down to -1, back up to 0. So this is like your parent function of sine. Those key points is what we call them, happen for my initial sine curve at pi over 2, pi, 3 pi over 2, and 2 pi, the quadrant angles, okay? So this is where it starts at 0, goes up, down, down, up. If you overlap this with your unit circle, and you're looking at your signs, right? So the sign, like the sine cosine. This is 1, 0, this is 0, 1, this is -1, 0, this is 0, -1. So if I were to focus on just the sine of these coordinate points, which is the y, at 0 it's 0, there's that coordinate point. At pi over 2 it's 1, there's that coordinate point. At pi it's 0, there's that coordinate point. At 3 pi over 2 it's -1, there's that coordinate point. And we come back around to the 2 pi and it's 0. So that's where these points come from, okay? I am going to teach you how to stretch these, shrink these, shift them up, shift them down, all that good stuff, okay? And a lot of that is based on the period of pi, which is how long it takes to make one complete revolution, which is 2 pi. If we extend this beyond, so 1 cycle, in this case, is the period, okay? If I ask you to give me more than 1 cycle, it just continues on that loop. So the same pattern happens over and over and over again. These are waves, okay? And they are cyclic. They continue to happen in the same. Just like if I keep going around my unit circle over and over and over and over again, those angles are the same. For the most part, I'm going to ask you just for 1 period, okay? But if it does say give more than 1 period, then you know just to duplicate the curve to the right or to the left. We start with the amplitude, which is how high and low my graph go. And the period, which is what I just said, how long it takes you to make one full complete curve. So if this is my original function, y equals a times the sine of bx, a is the number attached to the front of sine, b is the number in between the trig function and the x. So we find the amplitude by doing the absolute value of a. It is half the distance between the max and min. We go up the amplitude, we come back down, we go down the amplitude again, we come back up. So the full height on my sine curve is twice the amplitude. But I find the amplitude by doing the absolute value of a. I find the period by doing 2 pi over b. So again, that's how long it takes to complete one full curve, starting at 0, going up, down, down, up. Those are the first things we're going to find. Then we do all this. So we're going to identify the amplitude and the period. And then we're going to find the 5 key points. Now this says to take your periods and divide it by 4 and then add. I actually choose, because I have seen what happens when you add fractions, to take the period, once you find it, and multiply it times 1/4. Then do the period times 1/2. My iPad doesn't like this stylus. And then times 3/4. Those will get you your middle 3 key points. The first one is 0 until we shift this left or right. The last one is the period, again, until we shift this left to right. Those are called phase shifts. So if there's no phase shift, we find our 5 key points at 0, the period times 1/4, the period times 1/2, the period times 3/4, and then the period at the end. Then we're going to graph those on our x-axis. We're going to figure out what the amplitude is. We're going to go up the amplitude, down the amplitude, down the amplitude again, and then back up. All right, we start baby step our way in. So this says the graph of 2 sine of x. I want to identify the a, which is what? what's the number on the front of the trig function? 2. The amplitude is the absolute value of that, which is 2. Then I need the b. The b is the number in between the trig function and the variable, which is what? What's in between sine and x? 1. Good. So then I find the period. 2 pi over b, 2 pi over 1, which is 2 pi. So this is our standard period. We're going to start to learn these key points, but then of course we're going to mess with them. Then I take that period and I multiply it times 1/4, times 1/2, and times 3/4. Pi over 2, pi, 3 pi over 2. Those are our middle 3 points. The first point, until we get a phase shift, which is not going to happen for a little bit, is the 0. The last is the period. Good. Now I'm going to draw an XY axis. I'm going to plot my key points. 0, pi over 2, pi, 3 pi over 2, 2 pi. Then I'm going to mark my amplitude. So we said our amplitude was 2. I'm going to go up 2 on the y-axis, down to -2. With me so far? Now I plot my curve. So remember, sine starts at 0. It's here. Goes up to the amplitude, which is 2. Comes down to 0. Down to -2. Up to 0. There is one cycle of 2 sine x. Questions so far? So if I was to duplicate this longer, you don't have to find every exact point. You just need to extend it a period one way or the other, okay? So I would continue to do the same increments. These are like increments of 1/2. So the next one would be 5 pi over 2, then 3 pi, and so on and so forth, and then just duplicate it to the right or to the left. Doesn't matter how many which way you do it. All right, so what changes here? What's different between this example and the last one?
The A.
Just the A, which means the B is going to be the same, the period's going to be the same, my key points are the same. The only difference is how high and low I go, right? So I don't have to do all that work. I know the A is 1/2, which is going to be my amplitude because it's already positive. I know the B is 1, which means the period, because it's going to ask you for all these every time. The period is 2 pi, and I know my key points are going to be at 0, at pi over 2, at pi, at 3 pi over 2, and at 2 pi. If the B changes, the period changes. But if the B doesn't change, those are your standard points. Now if this is 1 and this is -1, then my amplitude comes to the 1/2 and the -1/2. So I start at 0, I go up only to a half, come back down to 0, down a half, up 0. So it's kind of like a sideways reverse S, and when we get into cosine, it's going to be important to know the difference. So think about that like that shape, kind of like your roller coaster shape, okay? It goes up and comes back down, comes back up again. Yep.
So since we do the absolute value of amplitude, it will never be negative?
Amplitude will never be negative. The negative is going to flip it upside down. So instead of going up, we come down. But the amplitude will always be positive. Has to be positive. All right, so now we've got to change on our amplitude and on our period, right? So my A is 3, which is my amplitude. My B is now 2, which means my period is 2 pi over 2, which is pi. So I take that pi, I multiply it times a fourth, times a half, and times 3/4. I get pi over 4, pi over 2, 3 pi over 4. I start with 0, I end with the period, which is pi. I draw my key points, 0, pi over 4. Now, if this was lapped on top of the other one, obviously it would be more narrow. So my pi over 4 would really be probably here if I compared it to the other one. I really don't care on your spacing as long as you're labeling your key points. Then this would be 3 pi over 4. Then this would be pi. So if I had overlapped them, or I had actually given you a graph that ended at 2 pi, obviously this should be shrinked. But if you're just drawing it freehand, I don't care if you space them out the same as long as you label them. Then my amplitude is 1, 2, 3, and 1, 2, negative 3. I start at 0. I go up to 3. I go down to 0. I go down to negative 3. I go up to pi. So I've stretched this vertically with the A, and I've shrunk it horizontally with the B. Questions so far?
So do you have to show like the shrinking, like making it longer?
If you're just drawing this like an open graph, I don't care if it's the same width as the other one. If you're comparing the two, realize that this would happen twice as often. So like if you put this on a graphing utility and you compare those two graphs, this is going to have 2 loops for every 1 loop of the other one. And it's obviously going to be taller. But if you're just graphing it, like if I give you a graph, which I have no idea what this test's going to look like yet, but when I get there, it will probably be a hand-drawn graph where you're labeling your key points and your amplitude and all that stuff. And for that, I don't care how wide you make it, as long as your key points are correct. Okay. But just know if you were comparing this on like a standardized test or something like that, that's what the difference would be. If there was an overlap, this would be much skinnier. Yeah. All right, so example 4 just says, start with, find the amplitude in the period of the following and then graph the function. So this actually is like directly related to what you just asked, okay? My A is going to be 3, which is my amplitude. But my B is actually pi this time. So when I find the period, it's 2 pi over pi. And the pi's cancel out and I just get 2. So if pi is part of your B, obviously you're going to get just a whole number. Or you're just going to get a number without pi. So then I would get 2 times a half, 2 times, not a half, a fourth. It'd be good if I went in order. 2 times a fourth times a half and times 3/4. So I'd get 1/2, 1, 3/2. First one is still 0, last one is still the period, which is 2. Plot my key points, 0, 1/2, 1, 3/2, and 2. My amplitude, which is 3, 1, 2, 3, 1, 2, -3. Start at 0, go up to 3, down to 0, down to -3, up to 2. Questions so far? Okay, so now ends with a phase shift. A phase shift is a horizontal shift, okay? So if I have something inside the parentheses, there's a phase shift. If I'm adding or subtracting, okay? If I'm adding or subtracting something from to the x inside the parentheses, this causes a horizontal shift. So all of this, like figuring out the phase shift, all this stuff, to me, like, I can simplify it a little bit for you, okay? You're literally going to set your parentheses equal to 0 and solve. And that's this whole C over B thing, okay? That's all it's saying. It's C over B, or take your parentheses, set it equal to 0 and solve. And that's going to be your phase shift. Then, once you do everything we already did, we would find the period, we would do 1/4, 1/2, 3/4, we would do the 0, we would do the period. After that point, we are going to add on our phase shift, then plot our points on our axis, then draw our curves. So once you do the 1/4, the 1/2, the 3/4, you add on the 0, you add on the period, then I add to each of these the phase shift. Now if the phase shift is negative, you're really subtracting it, and you're going to shift everything left. If the phase shift is positive, you're adding it, you're shifting everything right. It will always be the opposite direction of what you normally think about it. Like when we take something and we do transformations on it, if it said x minus 2, that's actually a shift to the right 2, right? And if it said x plus 2, it was actually a shift to the left 2. Same thing is going to happen here. But it naturally happens once you add the phase shift on. So immediately you should see there's a phase shift because there's something added or subtracted from the x inside the parentheses. That's your phase shift. These are the least fun, I'll be very honest with you. It's an extra step, okay? But you could do it. So I start the same exact way. Find the amplitude. A is 2, which means my amplitude is 2. B is what? Close. Well, sort of. I mean, in the grand scheme of things, you're close. But what's in between the trig function and the x? What's that?
4.
4. 4 is the b. So period is 2 pi over 4, which is pi over 2. So this is really narrow if we think about it in terms of our general one. It's 1/4 its size. Now I take that period and I do 1/4, 1/2, and 3/4. Pi over 8, pi over 4, 3 pi over 8. My first one was usually 0. The last one usually the period, which is pi over 2. Now here's where it's different. I have to figure out my phase shift. So the phase shift comes by setting this parentheses equal to 0. So if 4x plus pi equals 0, I would get 4x equals negative pi, divide by 4, X equals negative pi over 4. So that's my phase shift. It is negative, which means all these points are shifting to the left, which should make sense because in my initial equation, it's a positive and the horizontal always happens opposite. So from each of these, I am going to subtract pi over 4. So this is negative pi over 4. I have to give this a like denominator, so I have to multiply by 2 pi over 8. This is negative pi over 8. 0. This becomes 2 pi over 8. So pi over 8. Multiply by 2 here, and I get 2 pi over 4 minus pi over 4, so pi over 4. Now those are your key points. So with a phase shift, you're still doing the 1/4, 1/2, 3/4, 0, and period on the front and the end. But then you have to add or subtract your phase shift, whatever it if it's negative, you're subtracting. If it's positive, you're adding. Now you have to plan this out because I know I'm gonna have coordinate points to the left and the right of the 0. Okay, give yourself that space. So let me group this before I start moving. So all the way left is negative pi over 4, then negative pi over 8, then 0, then pi over 4, nope, sorry, then pi over 8, then pi over 4. Amplitude is 2. I start at 0. I go up to my amplitude. I go down to 0. Down my amplitude. Back up to 0.
What did you go down for pi?
So the pattern always starts at 0, then up, then down, then up. For sine. So 0, up, down, down, up.
Yeah, but then we start in the previous ones and when we started in 0 we would go up.
Because we started, yeah, we went up. But that's because there was no shift. This is our first point now. We just took that and shifted it left.
Okay.
Everything got shifted left.
Got it.
Yep. One more thing I want to show you, because then you could do a good chunk of the homework, is if there's a negative on the front, okay?